Let me introduce Insook Han, assistant professor from Temple University, and then she is leading this session. Thank you.
This is about the educational perspectives that can be related to the robot research. So the purpose of this panel presentation is to provide the theoretical perspectives of learning that can be applied in the research on children and robots. So historically, as you can see in this diagram, there have been many learning theories that view learning as a product of individuals' cognitive effort, which is the first, and that one on the left-hand side, learning as a cognitive process that focus more like individual cognition, while others think it's both cognitive and social process. So in that, the kids and children and learners actually learn in a social and cultural context. And also there has been an emphasis on the emotional aspects of learning. So based on the overview of each approach to learning presented in this panel, we would like to have an opportunity to discuss the implications from these learning theories to inform research and development of the robot-children interaction. So also, since we're interested in young children in particular, in this panel presentation, we'll also discuss developmental theory a little bit and how children learn effectively, especially in the domain of science learning. So all these theoretical presentations can hopefully help us lay a common ground that we can then move further to discuss potential of children's learning with robots. So these are 4 presentations that we prepared here, and each presentation will be around 15 minutes, and the rest of the session will be saved for the discussion. So the first will be embodied cognition, and I'll present that topic. And the second one is group cognition by Dr. In Jae and Dr. Kyung Kim from Northern Illinois University here. And the third one is social emotional learning by Dr. Vinci Caro. She's going to be in the video conference here, and she's the director of STEM learning at Evanston Learning Partners in California. And the last one is about early science learning by Dr. Ji-Yoon Yoon from University of Texas, Arlington. Okay, so I'll start my presentation first, and this is about embodied cognition, and at the end of the presentation, I'll just briefly discuss how it can be possibly applied in the research in children and robots. I'll give you an overview, very quick overview of embodied cognition first, because we only have 15 minutes, I cannot really go over. So in the cognition research, traditionally, perception has always been considered as bodily in nature, while conception and cognition has been seen as purely mental and independent of our abilities to perceive. So there has been a dichotomous view of understanding perception and cognition. However, more recent view of cognition, which is embodied cognition, emphasizes that our perceptual experiences, such as seeing and hearing and feeling and touching, and all these perceptual experiences are key elements to reach conceptual understanding, because our thought and knowledge emerge from dynamic interactions between our body and our physical world around us. So here, one area that has discussed embodied cognition for a long time is cognitive linguistics. So cognitive linguists have tried to explain our cognitive process of understanding linguistic expressions with metaphorical mapping process. For example, if you can see here, I have 4 different sentences that shows the expression of anger with particular metaphor. So for example, the first one, John exploded when he failed his exam. And Mary flipped her lid over Bush becoming president. And Bill got hot under the collar during the argument. And it made Sally's blood boil whenever she saw leader. So it's all taken from the book chapter. The reason that we can very easily understand what that actually means without further explanation is because we actually share a common biological reactions that we experience whenever we get very, very angry. So even though the language, understanding the language and linguistic expressions has been considered as conceptual and abstract from the traditional cognitive point of view, it is actually indeed very deeply rooted in our perceptual experiences. And that's the reason why it's really important that we need to focus on this deep root of understanding the abstract expressions in language. So that's from the cognitive linguist point of view. And the second approach, another disciplinary area that has an interest in embodied cognition research, is cognitive psychology. So cognitive psychologists explain how we understand a new concept with perceptual simulation. So for example, let's say that I have this picture of striped lavender sofa with the photo of it. But let's say that you've never physically, directly experienced that particular sofa. So the striped lavender sofa. So even though I have a picture of it here, but without the picture, when you prompted with the word of striped lavender sofa, the first thing that you're trying to do is try to imagine what it would look like in your head by using your imagination, and that's actually so-called perceptual simulation called by cognitive psychologists. So that kind of imagination and perceptual simulation is kind of come from your prior perceptual experiences of experiencing the color of lavender from different environments, and also the stripes that you saw from different objects, and also the feeling of the sofa when you sat on the sofa. So you kind of remember all these pieces of perceptual experiences and try to combine and integrate that in your head automatically when you're prompted with the word. So that kind of perceptual experiences that's pretty multimodal is a deep root and cognitive grounding for students when they encounter a new concept. So without that foundational perceptual experiences, it's really, really hard for students to even think about what it means when the concept is presented in the classroom. So it's very important that we need to figure out what kind of perceptual experiences the students are in need when they learn a new concept, and what's the related perceptual experiences that needs to be taught before presenting the abstract concept in math or science or language learning. So there have been various ways and studies that try to design educational interventions based on these embodied cognition perspectives. So, and one example is the use of whole body in learning spaces. So here, if you see in this picture, this is called the Meteor Simulation Game developed by Dr. Rob Lindergan in the University of Illinois. And here they use an augmented reality technology that allows students' bodily movement to be easily integrated in the virtual space. So it's a combination of physical and virtual spaces, but in between those virtual and physical spaces, students are using their own body to enact as a meteor in space. So in this augmented learning environment, middle school students take a role of an asteroid and develop an intuition about how objects move in space. And while they're interacting with objects, graphs and other visual representations were presented as well in a way that helps the students can connect their bodily movements to the abstract formulas in the physics domain, and which ultimately help learners to understand abstract science concepts based on their bodily experiences. So instead of just presenting a concept with the numbers and pictures and all these different traditional way of presenting the materials, this particular environment actually helps the students to engage with their own body so that the concept, along with other visual materials and abstract formulas, it can be really truly embodied in their physical activities as well. So while the first example that I just showed used the whole body in learning, there are some other studies that promote embodiment by providing multisensory experiences. So in this study, we try to develop a virtual learning environment where learners can see and hear and also touch some of the objects in the virtual space. So in order to understand the mechanical structure, learners can grab a part of the machine and rotate and zoom in and out while they are interacting with the object in the virtual space. So traditional multimodal multimedia learning materials only provide information mostly with the visual and auditory information, But in this virtual environment, they can use their own hand gestures to interact with the machine in the virtual environments. So that actually adds one more perceptual experience the student can experience, and then later they can combine it when they encounter a similar concept in a non-multimodal sensory in a way. So those are the examples of the study that's and the learning research that applied embodied cognition in the learning environmental design. And I just wanted to see the trends in the embodied cognition research, particularly in the learning domain. So I'm just in the process of analyzing some data, but based on the preliminary analysis, among 85 peer-reviewed articles that were selected for analysis, 64 articles were intervention studies, meaning that there were educational interventions that were designed to increase embodiment in learning. So among those 64 studies, as you can see here, around 35% of the studies specifically focused on young learners learning. The preschoolers are, I think in the previous discussion, are more of the focus of the children with robot, but they're only 3%. So it was kind of surprising because considering that the preschool age children learning in the developmental perspective, it's naturally multimodal, and they use their activities with the bodies and gestures and all the time, but it's not really very well examined, even though the embodied cognition very much focused and emphasizes the bodily experiences of the learners. So there is some needs of the research that needs to be conducted in the area. And in terms of the content-wise, among 85, including both intervention and the literature review that talks about embodied cognition in any types of learning situation, around 70% of studies focused on math and science and language learning. So it seems like that these three subject areas are those that have been traditionally considered highly abstract in nature, but are now studied more from embodied cognitive perspective with the emphasis of perceptual experiences. So in these studies, various embodied strategies such as the use of body and hand gestures, for example, in the mathematical learning, use of the gesture to explain some kind of quantitative relationship is really important from the teacher's point of view and the student point of view as well. So if the teacher uses the correct gestures that really emphasize the quantitative relationship when they explain something in the mathematical learning, then students learn better, of course. And in the other way, when the student asks to produce a correct gestures when they try to explain their problem-solving procedures, that actually helps students learning better as well. So the use of this body and the gestures certainly helps the students' mathematical abstract learning. And science is one of the domains that I just showed you about using the whole body to act out the movement of the planets. And also with the haptic and force feedback joystick, when they learn physics domain, they could actually feel the weight of the object or the force of rotating some gears and other mechanical systems. So it's not just about seeing and listening in the multimedia learning situation, they could actually feel the force and the physics learning. And the language, in the previous presentation, we saw the examples of using languages, using the iPad and just moving around while they're listening to the stories and all that. And that's also very heavily researched in the embodied cognition domain as well. So I'll just quickly explain what I thought that it could be applied in the child robot research. And the one example is the one that I just said about using gestures in the mathematical learning. And while the children are interacting with the robot can be a learning companion. So children can use gestures to use mathematical problem solving to robots, and then they can collaborate together. And the robot is really safe learning companion because they don't really develop any misconceptions by being taught by peers. So it's kind of safe. We don't have to worry about robots learning a misconceptions while interacting with other peers. So they can actually interact together and use the gestures. And also robot can be used as an evaluator if they can capture the student's gestures. And so the robot can evaluate children's gestures to assess their level of conceptual understanding. So there is a literature that's been already established in the learning and mathematical learning literature that states that there is a certain levels of use of gestures depending on their understanding of the mathematical concept. So the robot might be able to capture that and assess their understanding levels. And along the way, while they're interacting with the kids, robot can record all the interaction automatically so that they can produce a lot of data that we can analyze and think about how we can support the interaction, the use of gestures of students along the way. That's my topic. And the second one is the group cognition. So I'll just give it to Dr. Yin Yang.